Hi everyone. Today we are going to discuss about the module 2. Exclusively deals about the shear force and bending moment and various bending stresses acting on the body. This is only we are going to discuss about the module 2. So in this module 2, we are going to discuss about the various types of the beams and different type of the loading system, different type of the supporting system, practically what we are using in the field. Okay. Then basic definitions of the shear forces and bending moment diagrams. Okay. So first two chapter we are going to discuss on the basic fundamental concepts of the types of the beam, types of the different types of the load acting on the beam, and various shear force and bending moment diagrams of the different system of the beam that we are going to do module 2. So this module 2 main objective is learners to understand the shear force, bending moment, and bending stress in on the beams. And learners need to learn the different types of the beams and the tensor loading systems and various supporting conditions. Then learners to analyze the shear force bending moment in various types of the beam, exclusively cantilever, simply supported, and overhang beams. Finally, the learners to study the simple bending theory and various stress distribution in the beams. So these are the module to the objective of this process. Okay. So all we know before going to touch it, we need to understand what is by beam. Okay. So beam is a structural element which having a capable of withstanding the vertical loads. That's why we are saying the transverse loads. This transverse load applied loads to the support. Okay. So generally loads taken from the roof and roof should be transferred to the beam, then beam load will transfer to the column. Like that, it will go. The finally is going to end to the support. That is the foundation. It's going to end. Okay. Then what is in the support? Support is an element which bears, which will support the weight of the beams and kept it be upright. Which will be stable. Be stable. So we can say it is having a hinges which keeps the beam in a equilibrium condition. This is stable. Need to maintain the equilibrium condition. The support is required. The load as a concept refers to the forces acting on the structure. If you take the G plus 1 structure, what are the forces acting means? The loads acting from the roof and beam and column and slab. Okay, these are the things of the structure loads acting on the structure. So this is a reason. This also can be called as a structural load. These are load we can say for the structural load. So the load we can able to define for the point load, uniform distribution load, and we are triangular distribution load. Okay. So different types of the beam. First is the cantilever beam. The cantilever beam is a fixed rigidity, okay, at one end, and the other end should be a free end. Okay. Simply we can able to free end. The entire load acting on the beam is transferred to the fixed support. So what is the main key point we need to understand that the maximum bending moment occurs at a fixed. Okay. So example when you are seeing located for the balcony, sunshade and cantilever slab. So these are the example for the cantilever beam. Then what is a simply supported beam? Simply supported beam rests the to support. Usually hinges at the one end, other end should be a roller support will fix. Okay. So it's a free, it will be a rotate the support, but cannot be resistive bending moment. We are not able to resist the bending moment, but we can able to create it. Okay, okay. So what is the key point? No movement at support. In support, if you take A and B, they won't possible of any movement. So maximum bending moment will occur in the mid of the span only. So an example for a simply supported beam is a bridge girder, so linden and beam. So these are all for the simply supported beams. Then fixed beam, the beam fixed both ends and A and B are both ends are fixed. So rotation will be not allowed, okay, at the support. Example for the RCC frame structure is fixed for both ends. It won't allow for any exit. So horizontal movement, transition movement, and rotation movement, everything is arrested. Okay, not able to allow. Then other type of the beam is called continuous beam. So more than two support we can call it for a continuous beam. So beams resting more than two support. Example, multi-span of the building the beams. Now figure you can be able to show the different type of the supporting condition will be that above the condition slab only we are going to place the entire slab. Okay, which is a continuous beam. There are other type of the beam we can call for the overhanging beam. A beam with one or both ends to be extending beyond the support. So beyond the support, we can able to possible extending the structure maybe on one side or the other side also. Okay. So roof projection is a classical example for the for overhanging beams. So other is the proper cantilever, a cantilever beam with an additional support near to the free end. Look at the example, it's a long balcony with a prop we're going to fix. So what are you going to do? When you fix one end, another will be free. When you started to apply the load, the free end is going to down. Okay. Maybe chances to failure. So we want to prevent those type of support section. What we need to provide the support. That's why it's called a prop. Okay, we need to lift the structure, we need to overhang the structure. So we need to provide a support. That is a beam is called for a proper cantilever beam. So next different type of the loading system generally as a structure. And this three most possible we can able to see for the three types of loading system. One is a point load, uniform distribution load, so uniform varying load you can able to see. Okay. A point load acting on a single point on the beam. If you take a simply supported beam, it's like a single point. Only one point you can able to see a single point load. Okay. So in practice, loads are applied over a small area, but is idealized acting on the one point. Generally, the load we can take the units is kilonewton or a newton. So, example, load acting on the column load or machine load, it will be a single point load we have to consider. Next, uniform distributed load. The load is spread equally on for the entire length of the beam. Generally, we can unit you can call it a kilonewton per meter. So per meter, how much loads carry taken, we can consider for the UDL. Okay. Example, sulfide as slab or floor finish, or we can take an as a uniform distribution load. So another important load for uniform varying load, a load whose intensity varies linearly along the length of the maybe a triangular or a trapezoid. Okay. The unit is a kilonewton per meter. We will take. The example, the soil pressure, the reading on water pressure. These are all called for the uniform very load. Okay. So now you can see the simple example for the point load, difference for the uniform distribution load or uniform varying load. These are the classical example for the with the different type of the loading system. And coming to the different type of the supporting mechanism, all we know what is to be supported, the keep the structure stable and it will be equilibrium. So when you are placing the beam or slab, whatever may be, it won't be transferred. Okay, it keep properly equilibrium conditions. Okay. Then what is the support reaction? The support reaction, the resisting forces provided by the support against the applied load. When you started to apply, this supports need to resist. Then only the beam should be stable. For that, we need for a support. Okay, that is called the support reaction. The support started to react based on the external loading. Or we having a different classification of the support. One is a fixed support, hinged, or we can call it for a hinged support, or we have product support. What is be fixed? It be fixed. It be purely rigid. Okay. So both rotational as well as the translation movement will be totally arrested. That means this support can able to resist the horizontal as well as the vertical and movement loads. So making them the structures to be more strong and stable type of the beam of support it will be that. So how many reaction will come? We are arresting the three direction. One is horizontal, vertical, and movement. Automatically, the reaction will be a vertical, then horizontal, and movement. So let us see fixed support. We are having a three reactions. So when coming to hinged or pin support, the pin support allow the rotation movement, but does not allow for a transitional movement, both X direction and y direction. The pins support are stable resisting horizontal as well as the vertical loads, but not able to resist the movement due to their ability to rotate. Okay, it can be allowed. So they provide the two reactions for the injury or pin to support vertical as well as the horizontal. The roller support allows the beam move horizontally and rotate, but to resist the vertical movement. It's provided only reaction, that is the vertical reaction. So allows the expansion and the contraction due to the temperature. Example for the bridge bearing. Okay, it can move and it will rotate. Okay. Then we need to simple definition. What is shear force bending moment? Okay. As a weak diagram. Okay. The shear force at a section, the algebraic, all the vertical forces acting on the either side of the section is called the shear forces. What is the purpose of the main shear forces? To help the to resist the sliding one part of the beam over the another due to the vertical loads. It will use to check the safe against the shear failure, especially for the near support. So near the support only will be getting more shear forces. So based on the shear forces or beam charted to the resisting force are not need to check. That means where getting the maximum shear forces. What is it? Shear force diagram? It is a graphical representation showing the variation of the shear forces along the length of the beam, variation of the shear forces. What is the bending moment? The algebraic sum of the moment of the all the forces acting on the either side of the section about the section. Okay. What is the purposes? We need to determine the bending effect on the beam due to the external load. Then only we can design the beam safe against the bending failure and axis of deflection we can be able to find it. What is the bending moment diagram? It is a graphical representation showing the variation of the bending moment along the length of the beam, that is called for a bending moment diagram. Okay. So this small lectures we can able to understand the different type of the beams and like loads and various supporting condition. Then what is in shear force? What is the purpose of shear force and what is uh, shear force diagram and bending moment? Just we are discussing about it. So next we are going to see about the next segment for overall deep we can discuss about these topics. Okay. So again, this is a textbook we are using for strength of materials, SI unit, Dr. Vijayakumar. So thank you, learners, for the module 2 for fundamental concept of the definition. Next, we will see about the deep in the how to draw the shear force and the bending moment diagram of the different type of the beams. Okay.